Exponential growth is a specific way that a quantity increases with time. It occurs when the instantaneous rate of change of a quantity with respect to time is proportional to the quantity itself. Savings account with compounding interest are an example of exponential growth with a fixed percentage increase. Compound interest is the addition of interest to the principal sum of a deposit. In other words, it is a result of reinvesting the interest instead of paying up. Here's the formula for compound interest. V, which is the final value subjected to exponential growth, equal to S, the initial principal, times 1 plus R, the interest rate, to the power of T, which is the time in years. Here's the formula for simple interest. V is equal to S times 1 plus RT. Here's an example of applying the compound interest formula. The principal amount is $1,500 with an annual interest rate of 10% compounded yearly for 15 years. Applying the formula, the final amount comes to $6,205.85. Now, applying the simple interest formula with the same variables to the previous example, the final amount comes to $3,750. As seen from the previous examples, there is a vast difference between the two formulas. Simple interest is computed on the original amount without accumulating the interest earned. Therefore, simple interest is also known as the linear growth, and compound interest is known as exponential growth. Real-life application of exponential growth. Mike decides to start planning for his future, and he decides to apply a savings account at ABC Bank. The savings account is paying an interest rate of 10% compounded annually. How much would he have in his savings account after 20 years if his initial deposit was $5,000? Here's a graph illustrating Mike's savings account. The x function represents time, and the y function represents the value of the savings account with respect to time. Although exponential growth is often used in financial modeling, reality is often more complicated as there are many factors that will affect the returns. Age is one such factor that would affect the returns. A person who invests at an earlier age would have higher returns than a person who starts investing at a later age. Here's a famous quote from Albert Einstein. Compound interest is the eighth wonder of the world. He who understands it, earns it. He who doesn't, pays it.